and welcome to this brand new section called functions. Now this is the introductory lesson to functions, and we are just going to look at what is a function as well as function notation later on in this video. Now for every x value of a function, there is only one y value. Okay, so now we know that a function, for every x value, it has only one y value. As soon as one x value has more than one y value, it will not be classified as a function. Well, you can study that part if you want to, but luckily there is an easy way to see if a graph is a function or not. What we basically do is, and I'll start here with a straight line, we are just going to take our ruler and we assume that this red line is my ruler, and then we're going to put it to the left and we're going to move it as it is placed vertically. You are going to move it from left to right, okay? Now what we are looking for is that our ruler only cuts our graph at one place each time. So we start here, look, it only touches the graph at one spot. And we keep moving it one spot. I'm talking about where the red line is cutting our blue graph, right? One spot, all the way through. So this is classified as a function. Now, let's go to the one here in the middle. And there we go, it cuts it at one place. As I move it from left to right, it keeps cutting our function or our graph only at one place each time. There, right? Never more than one place at the same time. And I'm not talking about these arrows there, I'm just talking about the entire lines of this graph. Can you see it always cuts it at one place? Now, how about this one? So again, this parabola is also a function. Now, if we look at this exponential function, it keeps touching the blue line only at one place as I move my ruler from left to right. So this is also a function. But let's have a look at this one here at the bottom. As I put it down on the left and I move, look, it cuts my graph at two places at the same time when I place my ruler vertically over it. And that means that this is not a function. How about the circle here? If we move it, look, it cuts the circle there as well as there. So this is also not a function because it cuts my graph at two places. That means for that x value, there is two y values, and then it's not a function. And that is how we know whether a graph is a function or not. Now let's go and look at function notation. Now here is function notation. In grade 9, we wrote the equation for a graph as y equals whatever type of graph we were busy with, right? But now we will start to write fx. So instead of y, we write fx, and that simply means it's a function of x. But fx means exactly the same as y, okay? So it does mean y equals, but we just have a different way of writing y. We are writing it as fx, so it's a function of x. But we use fx or gx or hx to indicate different graphs. That's why we don't call our graphs y equal anymore, because we will have more than one graph on the same Cartesian plane, and then you need to know which one we were talking about. Are we talking about fx or the gx or the hx graph? Which one? And please remember, fx means exactly the same as y. So if I say fx equals 3, that means our y value is equal to 3. Okay, now, here is an example. If fx is equal to 2x squared minus 8, well, that means y equals 2x squared minus 8. And if we want to find the y value, we need to know what the x value is, right? So here our function is equal to 2x squared minus 8. What will the answer be for f? And then in the place of the brackets, we've got minus 1. Look, there we have an x in the brackets, and then we had 2x squared minus 8. Now in the brackets next to the f, we've got a minus 1. So what do you think is going to happen? We're going to take that minus 1, and instead of having an x in our function itself, we're going to put a minus 1. So basically, this will just be the following. So if we want to write f and minus 1, this is just going to become 2. And now we don't have an x in brackets. We've got a -1, so we cannot have an x there. We need to have a -1, right? So, and when we do that substitution, we're just going to put this new bracket with the brackets in x's place. So that is what was there originally, and now we have a -1 in brackets, so that goes into x's place just like it is written there, and you don't leave anything else out. And now we simply multiply all of that. So basically now the function when x is a -1 is equal to, and this will be 2 times 1 minus 8, and when x is a -1, our y value will be equal to 2 minus 8 minus 6, and there we go. So when x is a -1, our y value will be a -6, because remember, fx is the same as our y. So if we say f and -1, that basically means what will be the y value when our x is a -1. This is our y value when x is a x, okay? So there we go. And what will the new equation be if we have f x plus 1 plus 1? Okay, so that means we had a function fx equals 2x squared minus 8, but now instead of having the brackets and an x or an x there, we have x plus 1. So in the place of the x, we are going to write x plus 1, and then this entire function needs to go up one place. So look closely how we write this. This will simply be fx is equal to 2x squared minus 8. That was the original function, right? Now we're going to change it to this. So look what I do. We write there if, and then x plus 1 is equal to. So in the place of the x, we will put x plus 1 in brackets. And then we're also going to add 1 at the end of this function. So basically this will be 2, and in brackets we've got x plus 1 squared minus 8, and then we still have to plus a 1. Do you see what that means? Okay, excellent. So now we just solve for this entire new function, and we see what we end up with. So this will be 2 times, and this will be x squared plus 2x plus 1, and this will be minus 7. And the new function where x plus 1 equals 2x squared plus 4x plus 2 minus 7, and it's equal to 2x squared plus 4x minus 5. And that will be the new function if we change the x to x plus 1 and we add another 1 to our original function. Okay, cool. Now what will the new equation be if we have 2 times f, and instead of an x we've got an a? So what we simply do is we write down our normal function, which is fx equals, and then we had 2x squared minus 8, right? But now we want to change it to 2 times our function, but instead of an x we're going to have an a. So this will be 2 times, and then we've got 2, and then instead of the x we've got an a to the power of 2 minus 8. Okay, can you see? We're actually taking the entire new function and we're multiplying it with 2. That's what they are saying here, so that's what we're doing there. So that was our original function. Now we don't have an x, we've got an a, so in the place of x we put an a, and then we take that entire function and we still need to multiply it with 2. So this will become 2 times the function of a is equal to, this will be 2 times 2a squared minus 8. This equals to 4a squared minus 16, and there we go. Okay, excellent. So I hope you could follow here. When you need to change a function and they give you something new in brackets, you simply substitute that bracket into x's place. When they tell you to add something which is not in brackets, which is on the outside of these brackets, that means that your graph will move up or down. If it's a plus, it moves up. If it's minus, it moves down. You simply put the plus 1 or the minus value at the end function, and then it becomes part of the calculation. When there is a 2 in front of the function, well, it simply means that the entire function needs to be multiplied with 2. That's why I put the entire function in brackets and I multiplied it with 2. And there we go. Let's go and look at some more examples. Now let's run through all of these examples to see if we can determine the value of the following question. So we've got fx equals 2 divided by x plus 4, okay? So we've got a function of x and it's equal to 2 divided by x plus 4. See, the x is in brackets, that's why there's an x. So if there's something else in brackets, there must be something else in x's place. So now they want us to determine the value if it is f with a 1 when x is equal to 1, we want to know what the y value will be. So what we simply do is we equate this, and then it will be 2 divided by, and instead of having an x we have a 1, so in place of the x we put a 1 plus 4. So then we simply have here, and I'm going to write this in my black pen. So we've got the function when x is 1 is equal to 2 divided by 1 is 2, 2 plus 4, and that is equal to 6. And there we go. So what will this entire function be if we take 2 times the entire function? So that will basically be equal to 2 times this entire function of x. See, the x in the brackets didn't change. It stays fx. Fx is equal to that. But now we're going to multiply fx, or all of that, with that 2. And there we go. So this basically will become a distributive law. So that 2 times that, and the 2 times the plus 4. So let's write that answer. So 2 times our function when of x is equal to 4 over x plus 8, and we are done. And that's what will happen if we take the entire function and we multiply it with 2. How about number 3? So this will simply become the following. It's equal to, and then instead of having the x now, we are going to have x plus 1. So I'll just write this again here at the top. So we know that fx is equal to 2 divided by x plus 4. But now two things happens. Instead of an x, we have x plus 1. So we cannot have an x in our new function. We have to have an x plus 1. And then we have to add another 1 at the end. So this will basically be 2 divided by x plus 1 plus 4. And then we add a 1. And this is equal to 2 over x plus 1 plus 5. And that is what the new function will be. As easy as that, right? Now, how about the next one? If fx is equal to x squared plus x plus 2, determine the value of. Now, instead of having an x, we're going to have x plus h. So everywhere where we see an x, we have to put x plus h in brackets in its place and then do normal algebra. So this is equal to, and then we have x plus h in brackets squared plus x plus h plus 2. Can you see everywhere there was an x, we put x plus h now, because this is now a function of x plus h and not just a function of x. And now we multiply all of this out. Now this is where your algebra comes in. So this will be a x squared plus 2xh. You remember how this works? First times first gives us that. First times second times a 2xh, and then second times second, that will be a plus h squared. And this is now a distributive law. So we have plus x plus h plus 2. And now we go and see if there's any like terms that we can add or subtract. Well, there is no like terms here. So that is our answer, and we are done. Okay, if there was like terms, you will add or subtract the like terms and write the simplified version at the bottom. But there are no like terms here. And that is all there is to it. So I hope you understand this function notation. It is not that difficult. You just have to remember whatever is given to you in brackets goes into the place of the original thing that was in brackets. If we add or subtract something at the end, we want to add or subtract something at the end of our function. If we multiply at the front, the entire function, like this one here, if we multiply with the 2, then the entire function goes in brackets and we have to multiply the entire function with 2. Okay, and that is all there is to it. So great. In the next lesson, we will start with our linear functions. See you again. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.